Hello, my name is Pat Halpin. I'm a professor at the Marine Geospatial Ecology Lab at Duke University, and I'm going to be speaking today about approaches for spatial planning and specifically on area-based management tools. There are three different types of approaches that can be implemented to support the regional environmental management planning process. One of these is cumulative impact assessments. This approach will be the topic of a talk by Piers Dunstan a little bit later. And this approach uses models of pressures, impacts, and risks. Another approach is area-based management, which is what I'm going to be speaking about, which looks at spatial tools such as areas of particular environmental interest or sites in need of protection or areas or sites in need of precaution. And a third type is adaptive management strategies. These are the operational procedures during the actual implementation of extraction or exploration. These are not going to be discussed in this meeting at this time, so we're going to be discussing those into the future. All three of these approaches are very complementary, and they work at different scales and they cover different kinds of activities. So in addition to being complementary, the scales that these different tools operate at start out with cumulative impacts at a very broad bioregional scale, with the area-based management tools being implemented mainly at a regional environmental management plan scale. And then adaptive management is really conducted at the exploration or extraction scale. So they're nested and complementary approaches. So spatial management tools are going to play a significant role in the development and implementation of a regional environmental management plan. And so what we want to discuss today are the available tools, approaches, and considerations that go into area-based management. We're not beginning this with a blank slate. There's been a lot of work done in the past, and there's three processes that I want to refer to. One is the Regional Environmental Management Planning Guidance Document developed by ISEA that outlines the tools that are available for us in this process. Also, there was a recent workshop in Qingdao that looked at specifically at this region and at cobalt-rich crusts, and had a bunch of guidance that was developed out of that workshop that is very relevant to this process. Also, there's the CCZ process that's been ongoing for a number of years that is also very relevant to this current process. So we need to build on these existing processes as we move forward with this workshop. Just to use the outcomes from the Qingdao meeting, there was a document, the ISA Technical Report number 23, that looked at the region and looked at the area, and I think this is a good place for us to start. They identified a triangle that covers two different seamount regions and a abyssal plain basin region that are characterized as different areas that we're going to consider for spatial planning. I'd like to go through some of the highlights from that report just to get us started. So some of the highlights are, first, that the APIs, the areas of particular environmental interest, should protect biodiversity, integrity, and functions within that larger triangle area, the rim planning area that we're going to be dealing with this week. The general guidelines from the CCZ process should be used to think about seamount ecosystem complexity, and also we'll be working at multiple scales with the variability of individual seamounts, and plain areas need to be considered on their own and in context. The Qingdao report noted that we should avoid overlapping reserved or contract areas unless there's strong evidence that there is a reason to be overlapping with those areas. So we're going to need to look carefully at those topics. The API design should also consider the size and range of seamounts, full character of seamounts, and the integrity of the ecosystem. It was also suggested in that report that 30 to 50% of the region should be considered in a network of APIs that represent the ecosystem. Also, the CCZ process, while it's a good touchstone to begin with, differs substantially from the triangle area. So has different topography, different bathymetry. Also, the expected dispersal kernels that you would expect to have may be different in the triangle area versus the CCZ. And finally, the last point is that we should have future adaptation of the API design into the future. So these are a thumbnail description of some of the take-home messages from that most recent workshop on this topic. And I wanted to cover those as a way to get us thinking about some of the issues in this region. So thinking about area-based management tools in different types of deep sea mining environments requires us to think about different tools and different approaches. Polymetallic nodule ecosystems are very different than hydrothermal vents, which are very different than polymetallic crust areas. And in the region we're dealing with, in this regional environmental management plan, we're going to be dealing with two of these different types of regions simultaneously: polymetallic crusts on seamounts, as well as polymetallic nodules in plain areas. So what I'd like to do now is talk about different approaches that are available to us. These are coarse filter and fine filter approaches, and then the scales of area-based management tools. These terms are very, very general terms that have been used for many years in spatial planning processes. And the general idea here is that there are two different primary scales that you could work at when you're doing area-based management. Coarse filter approaches target the representation of broad ecosystem features and gradients, and fine filter approaches target unique sites that may be of particular high value or particularly high risk. APEIs are probably an archetypical example of a coarse filter approach. APEIs generally describe large areas with self-sustaining populations for a broad range of habitat variability. So these really are a classic case of a filter kind of approach, laying out very broad areas to be set aside. So this is just a table showing general API characteristics. So large area, self-sustaining populations, broad range of habitat variability with no direct or indirect mining effects. And just to use this as an example, the CCZ environmental management plan example took into account the biophysical gradients that affect biodiversity. They also ascribed that the areas should be large enough to contain species of interest. They should be surrounded by buffer zones, and the boundaries should be simple geometric shapes so they're easy to recognize. The sites also, in the CCZ example, ended up having originally nine rectangular API units that were 200 kilometer by 2 kilometer areas, and they had an additional 100 kilometer buffer on either side, extending them out to a 400 kilometer footprint. One thing to note is that in this case, the limitations in terms of our knowledge and data also affect our application of using large areas like this. And we need to consider that the lack of precision in our knowledge often forces us, when we're doing area-based management planning, to use a precautionary approach and look at large areas of ecosystems in hopes that you're collecting up the component parts that you need. So one thing we need to consider this week is how much of the CCZ example will be directly applicable in the Northwest Pacific, and what are some modifications that might need to happen to better adjust this type of approach to the current regional environmental management plan. Another example, thinking about it at a finer scale, could be the example of vulnerable marine ecosystems. So areas that are defined for their uniqueness or rarity, functional significance of the habitat, fragility, structural complexity. And so individual sites that are known to have these criteria may be sites that could be selected individually and separately using a much more fine scale approach. This is an example here of some FAO listed VME criteria. And on the left side, a map is showing some observations from OBIS, the Ocean Biogeographic Information System, on specific VME species observations for known species. So these are actual observed sites. And on the right side are modeled habitat suitability, which is a way to extrapolate information if these species may occur. So two different ways to look at these approaches. When we're thinking about these area-based management tools, we need to think about a collection of different tools. And the issues that have come up in the last year or so with ISA is the ability to define, in addition to APIs, site scale, fine scale tools in the ISA context. And so a new type of tool, sites in need of protection, has been described and was also described in the most recent Northern Mid-Atlantic Ridge RIMP planning process. So in addition to areas in particular environmental interest, sites in need of protection give us another toolbox to be able to identify more finely scaled sites. So the idea here is that we could combine coarse filter areas and fine filter sites to give us more flexibility in the design of area-based management tools in a regional environmental management plan. Also proposed was another category of areas or sites in need of precaution. These could be areas that are identified as potentially needing increased precaution because they may contain valuable ecosystem properties. So that's a third tool in the toolbox. And this is just a table listing these three tools: sites in need of protection, areas of particular environmental interest, and areas of increased precaution. So one thing we do need to consider is where and when and how we can apply data to this problem. And this is a topic for this planning workshop, to go from large area approaches, API approaches, to more spatially precise site level approaches. And the site level approaches are going to require very much more specific data on individual locations. So at the end of the day, we're hoping is that we could work together to develop a portfolio of area-based management tools that mix together both potentially large areas and specific sites where possible to give us the most flexibility to satisfy both mining interest and protection needs. The last topic I want to talk about are the implementation, and these approaches are all going to be applied using a criteria-based implementation approach. Criteria-based approaches can use quantitative regional analysis and or qualitative scientific expert judgment to identify criteria for different kinds of implementations. They can be based on individual species, ecological communities, habitats, or broader ecosystem characteristics. They also might focus on the inherent attributes and vulnerability of species. There are many different criteria-based systems. Here's just showing a table listing some of them from the CBD EBSA process, the FAO VME process, the IMO PSSA process, and many others. They have very common types of criteria based on uniqueness or rarity, biodiversity, naturalness, structure. So many of them are very, very overlapping in terms of the types of criteria. One thing to note, though, is these criteria are targeting individual sites or individual areas. So when we're thinking about applying these criteria, we're thinking about individual sites or areas, but often you need to have a regional context to be able to judge whether or not a site actually is important. For example, if a site is noted to have high biodiversity, you would have to have knowledge about the regional biodiversity to be able to evaluate it. So in some ways, the site value has to be compared to the overall regional value, somewhat like a numerator and a denominator in an equation. The application of describing sites is going to be conducted through templates to allow consistency between the descriptions. And this is an example of a template showing criteria and then the measurement or estimation of whether or not a site meets the criteria in a low, medium, or high level. So I just described in very general terms site-based criteria, but there's also another scale of criteria called network criteria. Network criteria deals with looking at a broader region and looking at the representativity, connectivity, replication, and adequacy of the overall system of areas that are being identified. So in some ways, site criteria might answer a question such as, are these specific seamounts important? Where a network criteria analysis could answer the question, should we protect 30 to 50% of this ecosystem? So these are two very different kinds of questions and two very different kinds of criteria applied in different ways. So building a regional environmental management plan and the area-based management tools in that process generally would provide a portfolio of both core scale areas supplemented with fine scale sites to hopefully create a representative system of habitat protection and vulnerable site protection. So our take-home messages here are that area-based management tools can be complemented with non-AVMT tools. Combined coarse and fine scale approaches can allow more flexibility in the selection of broad habitat areas and vulnerable sites. Spatial planning requires both site and network criteria. Increased spatial precision will require increased data coverage and detail. And defining the spatial extent of a RIMP is going to be a fundamental step in this planning process. Defining the tractable evaluation criteria is going to be very fundamental to the RIMP process, and we're going to have to acknowledge that adaptive management is going to need to occur into the future. Thank you.